Hey guys, so in this cycle we've been talking a lot about quadratic equations. Remember that just means an equation where my exponent is 2. So we looked at what are some key features. Last week we started to look at kind of solving them. So I want to remind you this is the standard form of a quadratic equation. It's y equals ax squared plus bx plus c, where a, b, and c are just numbers. So like here's an example. I have y equals 4x squared minus 3x plus 10. So this is like the standard form. But remember we talked about your quadratic equations do not have to have all the parts. So like last week, we saw things like this, where it's like x squared equals 36. So I had the x squared term, I had a number, but there was not this bx term. There was no just x term. And what we found last week is if this happens, we can just take the square roots, right, of both sides. We might have to do a little bit more. So I might have something like 2x plus 5 equals 25 or whatever, right? We might, squared. We might have to do a little bit of manipulating of our equation using our regular DCAM rules, but we can still take the square roots because all we have is this x squared term and then just numbers, right? There is no just x term. However, that's not always the case. So if I have an equation where I have all three parts, well, we have some different methods because we can't just take the square root. Because if I have like x squared equals 4x, and I try to do this, I can't take the square root of x, right? So the deal is if we get all three terms, or if we just have the x squared and the x term, this one doesn't even have to be there, but if we have the x squared and the x term, we have to start using some different methods. So what we're going to do is I'm going to stop because I want to make some shorter videos so it's not like one super long video. So I'm going to stop this, and in my next video we're going to talk about, well, how do we deal with it if we have all three parts?